Alright, guess what? Today we are going to create a view model for our application. This view model will be backed by our room database. So the first challenge that we have is creating the room database. And since room database is quite new, I hate creating it, but we have to. Although Android team claims that room database makes things very easy, and they might be right in a lot of aspects, but actually setting up room database is a pain still for a lot of people, including me, or at least me. Okay, let's create a new package in our application code structure and name it something like db. Yeah, I name it db. You could also name it something like model or similar. And then inside it, we need to create the structure for our database, for our room database. But note that before doing all of that, it's better to add room dependencies, room database dependencies. So what I do is go to theandroid.com, Jetpack, compose. I wished you would hear what I'm listening to. I'm using a new Firefox extension called World Radios, and it's really nice. I'm currently listening to Amsterdam Music Electronic, and it's just awesome. Jetpack, not compose, Jetpack alone. And here we are looking for a room. Come on, room, view more. Yes, room. We open it and we can find the libraries that we need to add. There we go. First we specify the room version, and then we will add room runtime, room compiler, room KTX, and room testing if we want to do testing, which I don't intend to do currently. Build.gradle in the app module. Room version, we can add it in this file, def room version, and the version seems like 225. Come on. This new line shortcut is different between VS Code and JetBrains IDE, and I hate it. Implementation, Android X, dot room, room compiler, room runtime, in fact. Room version, implementation, Android X, dot room, and room runtime, room compiler. But since this project is Kotlin based, we will most probably have to change it something different than implementation. It is kept Kotlin annotation processor, and also it says that add annotation processor to processor path using annotation processor instead of implementation. I don't know how IDE finds this, knows this, but thanks anyway. Thanks anyways, IDE. And then Kotlin extensions and coroutines. Kotlin room KTX, AndroidX room KTX, and sync the project. We wait for the project to be synced with the new libraries to be added. While it's being done, let's check out the things that we are gonna do. Oh, Compose has been updated. There's a new version for it. Alpha 7 is available now. Could not find method capped for arguments. You see this? Could not find capped. The method capped is not found. And this is most probably because we haven't applied Kotlin capped. Kotlin capped is another plugin that needs to be applied to our project before we can do anything with it. So id Kotlin capped, if I'm not mistaken, and unfortunately this page doesn't tell anything about it, but in other parts of the documentation regarding room you will find about it. Not in this page obviously, but for example in the room code lab you will find some mentioning of it. Once you apply Kotlin capped, Kotlin annotation processor, you will not have that problem anymore. And also let's update our Compose version. Actually, let's do it later because it can disrupt our current work, which is creating the database and etc. We will do that later. First, we are going to create our room database and our view model. And then we will use that view model to pass to different composables and manipulate data, etc. First of all, this is going to be a view model for costs, so it will have different data fields like cost name, cost value, and a table for costs. Actually, currently we will only have a single table and it's for costs, and one column for each row is cost name, the other column is cost cost value, and the other one, which is very important, is the creation timestamp or creation date, something like that. We need to have a clue when some cost is being created, you know. Okay, let's do that. Let's create a Kotlin file, Kotlin class or something. This is going to be a class. First of all, an entity. I'm gonna name it cost, class cost, and this is going to be annotated with entity from the room library. Okay, this should be a data class, and since it is an entity, it needs to specify its columns. All right, we need to specify column info. This is the annotation for each column that we have for our table. and then column info cost ID, column info name, I name it cost ID, and primary key, this is going to be our primary key, and auto generate, we are enabling auto generate, and I name it val cost name. Actually this is cost ID, this is going to be cost ID, or simply ID. Okay, ID is fine. And then another column cost name, and val cost name. Okay. Oh, the type are important. This is Kotlin, for God's sake. Int. And since it is auto generated, sometimes we don't pass in that, so it could be null. We don't pass the ID all the time, especially when we create a new one. Okay, so it could be null. And the cost name is a string. And the other one is cost value. This is going to be a double, obviously, val cost value double. All right, this is our entity, and I think we are done with it. Let's create our what is that, DAO. Let's create our DAO that will access this table from the database and work with it. Inside our DB. I'm gonna name it cost DAO. Note that every entity that you create has a corresponding DAO object. So this is our DAO, and DAO is an interface, if I'm not mistaken, because it will be created, it will be implemented by the room library for us, annotated as DAO, imported from Android X Room. Come on. And then here we can have queries for it. Let's see if I need to specify here something. No. Cast DAO query. We can have queries to return stuff, and insert and delete to insert and delete stuff. So queried, query annotation, we specify the query here, select all from cost, or from our cost table, and fun list. This is going to return a list. Get costs. This will return all the costs and return it in form of list cost. All right, another one is an insert. And it's going to insert entity the class name for this entity is cost class. Calling class. Do we need to specify anything else? Looks like it's not happy with us yet. It needs something more. Do you need this? No. I hate this setup. Cast.java, cast.class. What's going on here? One insert add cost, and this is going to get some cost parameter and add it. The entity, it needs obviously something else, and on conflict entity and on conflict strategy. Let's check out the code lab, what we are doing wrong. Fun add cost. This is going to receive a cost. And just add it to our database. Maybe we don't need to specify anything here. And then we have delete. Fun delete cost. And let's make this a vararg so that we can add more than one cost at a time. We can delete more than one cost at a time, and we can do that for add cost as well. So let's do that. Varargs cost. Entity K class. Too many arguments for public constructor delete. Why? Remove argument. Come on. So we have query insert delete. Let's make this a vararg as well. I always try to do this without checking out the documentation, but since this is a pain, it makes it impossible to do that without to do it. So let's create the database. The final part. The database, let's call it appdb. And this is gonna be an abstract class, and it's gonna be annotated with database. And this will be used by Room to create our database. This needs some Yeah, this annotation gets some parameters like entities, like how many tables you have in this database. We need to specify them in an array. So we create an array here, and since we only have one entity, I mentioned that entity only, and that is cost.class. Okay, and the next thing is views, which I don't need to specify the version. The version, I put it as 1 for now, and this was wrong, cost.class Java. Since this is a Java library, seems like I need to specify entities this way. And wait, actually this array this array symbol is not accepted. I need to use array of, looks like. No, it doesn't work. Entities, cost, okay. Class. Let's check out the other. Only const val can be used in constant expressions. Const val, constant expressions. Class. What? Really? It worked? Okay. So this is the way we specify classes in Kotlin. Something that we have to implement in a database class is a method that creates our DAO, and that returns our DAO, gives access to our DAO, and that is cost DAO fun cost DAO, and this returns cost DAO, and it has to be abstract because this is an abstract class. It needs to be an abstract class, abstract method. And then we need a method to return the database. So we create that method. This is a singleton, so I create a companion object, and inside it we return create and return fun get database. Note that since we want to get only one instance of the database, we create a single instance here. We create a static field, a static member of the class, and we name it instance. Okay, its type is our appdb database, so I create it this way. Let's define it. Val, it's var because it's volatile and it can be changed. Val instance, and its type is appdb. It's nullable. Okay, it's nullable, so I give it an initial value of null, and then inside get database we call room database dot builder. This builder requires some parameters. Room dot database builder. Yeah, room dot database builder. This is the thing that we use, and as you can see, it requires a context, so we need to pass in a context here. Context for our get database method. Database builder, pass in the context. What is the name of the database class? It is appdb. Class.java. Come on. Room database appdb. Required room database. But got appdb. You are going to create this type of database, okay? Let's see if we can fix it. Appdb class. Yeah. And the name. The name, this is the file that will be used as a SQLite database on our device, on our mobile device. So let's name it something like costdb. Yeah, costdb.db. Database builder, come on. Room database, context, class. This is the class. Okay, let's specify the type of the database that is going to return. It's going to return appdb, okay? Probably this will fix it. We need an appdb from you. Get instance. Okay, class calling class. It shouldn't ask me for the database abstract class database appdb. This database builder context and cost. No, it's not cost, it's the appdb. Java class maybe. This is the class for the database, and it should be right. Abstract class. Let's see if we did everything correctly. This is the entity data class. Okay, entity is correct. And the DAO is interface, and we did it. Okay, what about the database? Add a room database. Public abstract class. Oh, I forgot to inherit from room database. So we specify the class name, and the class name for our database is appdb.class. class.java. Okay, and finally we can build it. This returns an appdb. Okay, this returns an appdb. What is this error for? You return a function with a block body. Okay, yes, I'm not returning anything yet, and that's because I need to kind of instantiate this instance here. Let's see what happens if we put this inside instance and then return instance. This is the difficult part because we need to return appdb, and the smart cast appdb is impossible because the instance immutable property that could have been changed by this time, and we cannot cast instance to appdb. If we do that, it won't work. It works. This might not be successful anyways. So what Android documentation does, the way they do it, is to put this inside a block of instantiation, synchronized this. They do this inside, they do initialization inside this block. First they create a val instance, they put it here, then they initialize instance with instance, and then they return instance. Yeah, this should do it. Let me pause the video for now. I'll be back soon. Alright, now we return the instance, but this is not a good way. Actually, we are always mutating the value of instance. First we need to check if instance is already instantiated, and this is all the benefit of creating a singleton, to prevent creating extra instances and using a lot of resources. So what we do is, first, if instance is not null, then return it. Return instance. Come on, if it is not null, I'm doing a check here. It should be allowed. Maybe we should do that inside synchronized. No, it doesn't make a difference. If instance is not null, return instance, synchronize this, val instance, build instance, return instance. Let's see how they do it. Build instance, return instance. So they say if instance is not null, return it. Other than that, create it and then return it. I am doing the same, but is not null. then what's the difference? Return instance if it is not null. If it's null, then return this instance. Okay, it's a little bit ridiculous. I was doing the same check, it would essentially do the same thing, but it didn't work. Alright, get instance returns an instance of our database, and I think we should be good to go. Just let's the final check. Oh, we probably need also repository and the view model. We need, obviously we need the view model. Let's create the view model. Let's name it cost view model. Okay, and it's gonna extend view model. Yeah, it has a constructor, class view model, and it gets a repository. The repository is a place where we access to different sources of information, like from the database or from the network. Let's add the repository as well. So when you pass in the repository to your ViewModel knows how to retrieve the data based on the given repository. Yeah, repository. Create a repository. Cost repository. This is a class. Cost repository. And it gets one DAO. Cost DAO. Cost DAO. Costs. All the costs. And then it's using flow for getting the data. Flow list of cut Linux coroutines flow. Yeah, we are using flow from cut Linux coroutines. List of cost. And we get that from cost DAO dot get costs. And get cost doesn't return flow. We need to change that to flow. Now it's fixed. And this flow is something like live data that automatically updates the thing that you want, that you are fetching. If it changes, it gives you new instances of that and updates the return value. And then worker thread, what is that? Unsuspend queries of the main thread, therefore we don't need to implement anything else to ensure we are not doing line running of the main thread. This is something new. The worker thread wasn't here. It's just essentially saying that don't do this on the main thread. Do this on something else, like a worker thread or something. So suspend fun insert. Insert. Do the inserts here. Fun insert cost. Or add cost. Let's make it similar to the DAO method. Add cost. And make it suspend function suspend function, get a cost, and do that in the DAO, cost DAO, and cost DAO at cost. This is not suspend function, but it can be called from this suspend function. It's weird. Yeah, this is suspend function, and then room runs suspend queries of the main thread. Redundant suspend modifier. Oh, this is the redundant thing. We see this as redundant, but actually it's not redundant. Yeah. Worker thread. I don't think we need that, because Android automatically knows how to run them of the main thread. Okay, now that we have this, get all the costs, add cost, and delete also. Suspend fun, delete cost. Let's make this var arc. Required cost, but got array cost. Yeah, we can have more than one cost. Okay, we will try that. Delete costs again. Cost. This is the tricky part. I think we don't need to specify a var arc here. Cost DAO dot delete cost. This suppresses the error, but I don't think this will work, because looks like the delete queries need to work on a single argument. Like you pass in one argument, this cost, and you want it to be removed from the database, not an array. I don't think we can test it. Okay, that's it for now. I think we need to continue in another session and complete our view model. Just let me complete the view model before we wrap up. View model gets access to the data from a repository, val costs. See, it's quite a pain. Yeah, we get live data of cost, and live data of list of cost actually. And we pass in the repository here. Repository, cost repository, repository. What is that? Live data list cost. Repository costs. Yeah, the type. Well, costs. As live data, yes. As live data, because it's a flow repository. Costs as live data. Do we need to call collect? Collect as state. Look, our repository was returning what? It was returning a flow of list. Okay, okay. Now why this doesn't work? Repository costs. As live data. Will this work? I need to work on this. Seems like there's a problem. Fun insert. Let's do that. Word cost. I was hoping we can make it vararg. ViewModel scope. Launch. And if I'm not mistaken, this is an extension function, and yeah, this is an extension function on the coroutine scope class. And what this does, we do something inside the repository that insert. It's weird, repository is not known. Yeah, it's not known because we haven't defined it as part of the class. Shit. Sorry about that. As live data. Private val. Repository. Add cost, okay. Add the cost here. This could be more than one, so add a star before it. looks like this is how Kotlin works. And what is that factory? This was not here before. Now we have a ViewModel factory. Okay guys, I'm gonna wrap up this video for now. I will fix any problem and find any problem that we have in this code, and in this video, in the next video, we will continue developing on this, and we will complete and use this view model inside our compose application, and hopefully that would be much more fun than this view model and room pane. Sorry for the a lot of inconvenience that we had in this video.